Okay, today in class we are looking at graphs and writing equations from them. Okay, looking at graphs and writing equations from them. So we're going to get all of our attributes, amplitude, the period, the phase value, and then your vertical shift. And finally, we're going to write an equation. Okay, so we'll start with the amplitude. Actually, let's start with something before the amplitude. Let's start with the midline. Okay, the middle of this graph, hopefully you can see, is what? It's the x-axis is the middle of the graph. Okay, we can always tell the middle by looking at the max and the min. So here we have the maximum, and then there we have the minimum. Okay, in physics, this is called the displacement. Right, this is the total displacement of your wave. This is displacement. That's okay. So the displacement goes from a maximum of +2 to a minimum of -2. So in other words, this gets displaced 4 total units from max to min. Okay? The total displacement of this graph is 4 units. So the amplitude is always half of the displacement. So if our displacement was 4, from the bottom to the top is 4 units. If we divide that by 2, then we have an amplitude of 2, and we can put amplitude in there. But I was looking at the midline. Okay, if we're going to calculate the midline, right, the middle, we're going to take the maximum y value, so it has a max value of 2. We're going to add the minimum y value of -2, and we divide that by 2, right? The middle, or the average, 2 plus -2 divided by 2 is 0/2, which is just 0, right? So there's no vertical shift because your midline is 0, aka the x-axis. So if your midline is the x-axis, there's no vertical shifting. Okay, the period. How long does it take to do one complete cycle? Right, that's what a period is, one complete cycle. So from the period, let's look from the maximum here to another maximum. Right, that is a good way to find one complete cycle. Or if you want to, we could do from a minimum to a minimum. Or if we want to, we could do from 1 0 to the third 0, right? Those are all representative of one complete cycle. So either way, one of those 3 ways is how we're going to calculate our period. So if we start at the y-axis, which is 0, and we end here, okay, this graph has been labeled pi as your period. So the period is one complete cycle. In this case, it takes it pi units to complete one cycle. So this has a period of pi. And sometimes that's kind of difficult to determine based upon your graph. How clear is your graph? So maybe if you have a ruler, you can make a vertical line and actually see. And then the phase shift. So here's how we determine a phase shift. Does your graph cross the y-axis at a normal place? That's the question we have to ask. Does the graph cross the y-axis at a normal place? So what is normal? Well, normal is either a maximum or a minimum if we're talking about cosine, or the origin if we're talking about sine. Those are your normal places where your graph crosses the y-axis. Cosine crosses at a max if it's positive. Cosine crosses at a minimum if it's a negative cosine. And then sine always starts at the origin, or 0, 0, or wherever it crosses the midline. Okay, so is this a normal place? Yes, this is a normal place. It's starting at a maximum, so there is no phase shift because it crosses your graph at a normal place. Okay, so let's use this information to write an equation. The amplitude is going to be 2, of course, because there's an amplitude of 2. Now, is this a sine graph or a cosine graph? This is probably going to be a cosine graph because it starts at a maximum, right? That's a normal place for a cosine to start. Period is pi, which does not mean that pi goes into our equation. Remember, the period is always 2 pi divided by b. b is what goes into your equation. So we need to do some calculations to figure out what b is. Well, we just simply need to switch these two, and that will tell us exactly what b is. 2 pi divided by the period. That's how we calculate your b value. The period does not go into your equation. The b value does. So 2 pi divided by our period, which is pi. Okay, our period was pi units. 2 pi divided by pi is 2. So 2 cosine of 2. And now, depending on what your teacher wants, you can either put an x there, 2 cosine 2x, or if they're more formal, you can put cosine of 2 theta, right? Theta is your variable for angles. X works just fine also, right? And then, of course, that equals y or equals f of x, or something of that nature. Okay, so we're identifying the period, we're identifying the amplitude, we're figuring out if there's a phase shift or a vertical shift. Those are our attributes. And then we always calculate your b value from the period. The period never goes into your equation. We always have to find its b value. Okay, look at number 2 here. What is the amplitude of this graph? Well, if we look at the total displacement, that's from positive 3 down to negative 7. Positive 3 to negative 7 is how many units? Sorry, not divided by 10. What am I thinking? Divided by 2. So 3 plus 7 is 10. 10 divided by 2 is 5. So this graph has an amplitude of 5. Okay, so the total displacement is 10 units from negative 7 to positive 3. Right, that's 10 units. And the total, and then divide that by 2, and that gives us an amplitude of 5. Which means that the midline is 5 units down from a max. The midline is going to be in here. Okay, so remember your midline is 3 minus 7 divided by 2, which is negative 4 over 2, which is negative 2. So this graph has been vertically shifted 2 units down from the x-axis. Okay, 2 units down, which means it's going to be a minus 2 when we get to your equation writing. Okay, let's look at the period. So I'm going to go from a max to a max. That is going to be one period, one cycle from a max to a max. So let's look at this far. Okay, so the question is, what represents each of these tick marks? How far is each tick mark? Okay, if this is 1, 2, 3, 4, 5 tick marks to get to 25, that means each of these tick marks are 5 units apart. Right, so there's 5, 10, this is 15, that's 20. This is negative 5. Okay, we have to decipher based upon our labeling what is the value of each of your tick mark, each of your units. Okay, so then from negative 5 to 25 is a period of 30 units, right? 30 seconds, 30 minutes, 30 feet, I don't even know, right? Just 30 units. So this graph has a period of 30. Okay, so we have to decide what are each of our tick marks valued at? What is their length? What is their whatever? Okay, and then the phase shift. Okay, does this cross at a normal spot? right? No, it does not. So the question is, how far has a normal spot been moved? How far have we moved this maximum point away from its norm, away from the y-axis? And if we're looking at it, it's been moved 5 units in what direction? 5 units left. Okay, it's been moved 5 units to the left. So that's what we're going to come in here as our phase shift. It's been moved 5 units to the left. Lots of 5s in this one. Okay, so the phase shift, does your graph cross at a normal place? Does it cross at a max or does it cross at a 0, right? If it's a sine, then it crosses at 0. If it's a cosine, it crosses at a max. Those are the norms. Okay, this does not cross at a norm, so we have to see how far has that max been moved away from the norm. So now that we have all of our information, we can write our equation. So first, let's come over and calculate your b value. B is always 2 pi divided by the period. 2 pi divided by the period. So 2 over 30 reduces to 1 over 15. So that's going to be our b value. All right. Y equals. Starts off with an amplitude. Are we saying this is a sine or a cosine graph? If we moved the maximum point, then it's going to be a cosine graph. Right? If we moved the 0 point, then it would be a sine graph. But let's say we moved our maximum point, so it can be a cosine graph. 5 cosines of, here's your b value, pi over 15, parentheses, since we have a phase shift, we're going to put our parentheses in here. And since it goes left, that is a plus inside of your parentheses. X plus 5. Okay, so notice the b value is outside of your parentheses and your phase shift is inside of your parentheses. And then the last thing is your vertical shift, which is down 2, so that becomes a minus 2, the vertical shift. Where is your midline? Okay, so this equation has almost everything, right? And the tricky part is you can write a sine equation for this, or you could write a negative cosine equation. You can make this into any one of the 4 sine or cosine positives and negatives that you want. Okay, the only thing that changes is the phase shift. Okay, so if you make this into a sine, that means your phase shift has gone to the right, and you're going to have a minus in there. Okay, you might also have a negative in front of here. So there's some things that can change to give you a sine equation or a cosine equation. Okay, just make sure you can justify your equation by all of the work that you show. Okay, one last example. Amplitude. Okay, we're looking at total displacement from positive 7 to positive 3. That's a displacement of 4. 4 divided by 2 is 2. So the amplitude is the total displacement divided by 2. Amplitude of 2. Okay, and then your midline, right, your vertical shift is 7 minus 3 divided by 2. That's the middle, right? Your maximum value minus your minimum value. Sorry, not met. It's actually plus 10 divided by 2 is 5. Okay, it just took me a second to look and didn't look correct. So here we have the midline through y equals positive 5. So 5 units up has been our vertical shift. That's where your midline is. Add your 2 maxes and mins together. Add your max to your min. 7 plus 3 is 10. 10 divided by 2 is 5. Okay, so now let's look at the period from a max to a max. So if I travel down here, that hits at 5 pi over 6. And if I come down from this max, that hits at negative pi over 6. So how far is it from negative pi over 6 to positive 5 pi over 6? Okay, the answer is pi units. So we can count the tick marks. We go 1, 2, 3, 4, 5, 6. We do 6 tick marks from the max on the left to the max on the right. And if each tick mark is pi over 6, then that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. 6 pi over 6 is just pi. Okay, so now let's look at our phase shift. And just for fun this time, let's call this a sine graph, although we could very easily make it a cosine graph also. But let's start with a sine graph. So here it would be a 0 for your sine graph. So how far has your sine graph been moved away from its normal position, which would be where the midline crosses the y-axis? And it looks like it's been moved pi over 6 units to the right. Okay, that point has been moved pi over 6 units to the right. Pi over 6 units to the right. Okay, so we're going to call this a sine graph just because we haven't done a sine graph yet. But you don't ever have to, unless it looks obvious that it's going to be a sine graph, make it into a cosine graph, whatever is easiest. Okay, so our equation y equals amplitude of 2, and we're calling this a sine graph for fun. The b value, right, the b value for your equation is 2 pi divided by the period. So this has a b value of 2. Okay, and then your phase shift, if it goes to the right, that means we have a minus in your parentheses for your phase shift. And then we have your vertical shift of 5 units up. Okay, now there's one more thing to think about here. If this is a sine graph, sine usually goes up if it's positive, but our graph is going down, which means our sine is going to be a negative 2 sine 2 parentheses x minus pi over 6 plus 5. Okay, so just for fun, let's see what would change if we made this into a cosine graph. Okay, because to me it looks like it's going to be a cosine graph, so let's make it as if it were. For a cosine graph, we've been moved pi over 6 units to the left. Our maximum has left of the y-axis. Okay, so how does that change your equation? Well, it does a very slight change. Y equals still an amplitude of 2, cosine still a b value of 2, but now since we moved it to the left, there's a plus in your parentheses for your phase shift, and then still a plus 5. So the first difference is it's a positive cosine because it starts at a max. And the second difference is it's a plus in parentheses because that maximum has been moved to the left of your y-axis, not to your right. Okay, so you can write usually whatever trig graph you want, sine or cosine, as long as you can justify your equation with your work, then they are both going to be correct. Okay. Happy writing equation day.